Okay, so hello everyone. I hope you can hear me. Yes, perfect. Okay, so hello again. Today I'm showing to you our Google Summer of Code students. So I will do a very brief introduction because we will need to watch 6 videos from our students. So like this I will try to be fast. So for those of you who do not know, I want to just quickly introduce Google Summer of Code. This is the program from Google for open source projects, where basically open source projects can select some students who will work for them during the summer. The projects mentor the students contribute to the projects, and Google pays money to the students. That's the general idea. So every year from Pharo community, we apply for this program, and about every 2 years we get accepted. So this year, again, we got accepted. We received 6 slots for students, and we got 6 amazing students that did very nice projects that today we will be sharing with you. I will now quickly jump to show you this project, but here on the screen you can see the titles of the projects and the names of the students, and maybe I will also make it darker so like that you can see the screen. I just only wanted to emphasize that next year we will again start applying, so just that you understand what is the procedure. Any one of you, any member of the community is very welcome to propose their project ideas. So around February, we have a list of projects, and around February, we will be doing application. So this means that in winter, in December, January, please contact us and send us your ideas of any projects that you think are suitable for students. We compose a list of them, we make an application, and then if we are accepted, then students can select your project, and you can work with them during the summer, and students will get paid. So, and here you will see some examples of the cool projects that our students do. So just a second before I start the presentation, I will try to, yes, magic. Okay, it should be fine. So now we start with the first project from the Carolina, and I think her mentors were Juan Pablo and his 2 other students from Bolivia. So please, and
Hello everyone, my name is Carolina. In this video I'm going to talk about my contributions to Pharo as a part of my Google Summer of Code. My proposal is to improve the Doctor Test tool. If we open the Doctor Test tool, as you can see, this tool has different plugins. Every plugin analyzes the test on the Pharo system from a different perspective. So far, I have worked on improving some features of the Doctor Coverage plugin in particular. But first, let's see how it worked before. After you select a package and run this plugin, it shows a grouping of uncovered methods and the overall code coverage. That's pretty good, but this can be improved and have a more powerful tool. So along with my mentors, we decided to add these features, highlighting covered and uncovered lines by color, then grouping by class, and finally coverage code by method. Now let's see how it looks with these improvements. After running the coverage plugin again, now we have 3 groups. Uncovered methods, the grouping we had before, partially covered methods, methods that have been executed by the test but not completely, and then covered methods, methods that have been executed completely. Then one of the improvements is the grouping by classes, providing a clear organization and finding more quickly a concrete method. And next to the method, the coverage code appears in parentheses. In this case, it shows 0% because this method is in the uncovered methods group. If we select a method, we can see the uncovered lines highlighted in red. Something similar happens with the covered methods group. Each method has 100% and its covered lines are highlighted in green. favorite and most useful part is the partially covered methods group. Here we can see that the coverage cost varies from method to method, and so their highlighted lines were green and red and separated by the yellow color, which means that the statement is not completely executed. For example, in this method you can see that the false condition statement has not been executed. Same case with this method, in the do statement is not completely executed. And so with the rest of the methods in this group. With this, I finished the video. I hope this can be useful to you. Thanks.
Thank you very much. And the next video will be from Kevin. Kevin was the student from Bolivia, and his mentors were Milton and myself. He was working on the, and also some other people, just a second. But no, Milton, myself, Iona, and Noor, yes. So Kevin was working on the charting library for Rosa. This is a pretty interesting project. Please.
Hello there, I'm Kevin Cespedes Arancibia from Cochabamba, Bolivia, and today I'm going to show you the work done during my Google Summer of Code with Pharo Consortium. So, my work this summer had been to improve the chart library in Russell Free. Russell is a framework to visualize data with Pharo. It's an agile visualization engine with a great number of capabilities and applications. With Russell Free, you could create from charts, graphs, UML, to complex visualizations and animations. The chart library is just a part of Russell Free. Chart libraries have the important goal of simplified chart creation, with customizable templates enable users to focus more on analyzing data and less on how to build a visualization. In this context, Russell had some missing plots. The first one was the density plot, which, similar to violin plot, uses the kernel density estimation method to calculate the density function of a dataset. I abstract this method in a class called kernel density estimation, which could accept different kernel functions, by default a Gaussian normal function. But what represents a density curve? It represents the distribution of a dataset, how probably is to find a certain value in the dataset. It's very similar to an histogram, which depicts the frequency. The difference is that the density plot uses the KDE method to estimate the distribution in a continuous interval. Using this way to calculate KDE, it was easy to create the violin plot. After this, my mentors and I noticed that violin plot, box plot, and even bar plot share some ideas or abstractions, and we create a new abstract band plot, which is in charge of bandwidth and band offset. The importance of create this abstraction is that it will make much easier to create another band plots in the future, like even plots. And all of those share some cool behavior that now I will show you in a live demo. As we can see, now you could create one box plot from a collection of raw numbers, or use a collection of collections to create two or more boxes. You also can create violin plots in this way. You can customize the colors of all the shapes using one color or a collection of colors, one for each shape. Even if you want, you can customize the style of only one of the shapes, and also customize each one of the elements that compose it, like the median line or the borders. The use of models is one aspect that differentiates Russell from other chart libraries. In this example, we have two objects that represent competitions of the World Athletics Championship. You can create plots just by passing the models to them and using a block to specify the way to get the data. In this case, we want to compare the distributions of the athletes' time marks expressed in seconds and categorizing them by gender. One One cool thing of create the plots in this way is that you can inspect the shapes and you will be able to see the models that represent. Also, we have included an integration with DataFrame. In this example, we are using 2 Pro dataset. You can create a violin or a box plot just by passing the data frame and specifying the data column of which we want to know the distribution. If we want to categorize the data using a categorical column, we can do it. And each one of the shapes show us just the data related to one category. Also, we can categorize the data a second time and compare the violin plots side by side using a hue. And now all the band plots can transform themselves into horizontal, not by using another class like before, just by using a selector.
Thank you very much. The next video will be from Joshua Diaz Barato. He was our student from India. He worked on the improvements of data frame under the supervision of Cyril, myself, and Larissa. So, like
Hey
this.
everyone, my name is Joshua and I've been a part of the Google Summer of Code 2023 program with Pharo Consortium. This summer, I worked on the data frame project in Pharo. Over the past few months, I've had the incredible privilege of working with my mentors, Cyril, Larissa, and Alexander. Today, I'm excited to walk you through the contributions I've been able to make to the data frame library. During the first coding period, my focus was on implementing key features and fixing some of the existing bugs in the data frame library. And in the second half, I worked on making the data frame inspector more interactive, which I will demonstrate later in the video. This is how the default data frame inspector currently looks like. I implemented a method called toMarkdown which can convert a data frame to a markdown table as you can see in this image. You can also convert data frames to latex tables as you can see here, and you can even convert a simple data frame to an HTML table. I added a describe method which can statistically describe a data frame as you can see in this data frame report card which has various subjects of different marks of some students, and on the right side you can see the data frame inspector which has the statistical measures of each subject such as the mean, the median, the minimum marks, the maximum marks obtained in that subject. I also added methods for chain sorting. As you can see here, I'm sorting the report card in descending order of the physics marks followed by chemistry and then maths marks. I added a method to encode objects into one-hot vectors. As you can see here, you can encode integers and Roman numerals. You can also encode strings as well as large numbers and decimals. I have implemented some more features which you can check out in my blogs or the data frame repository itself. To use the interactive feature of the data frame, you need to load the Pharo AI data frame inspector using this code. This is a data frame called TV show, which has different column names such as the name, the season, the episode, rating, and nomination of each episode. Let's go ahead and inspect it. You can see there's an interactive feature which has the edit, sort, and search options. Let's try to edit it. So we'll change the rating from 3.9 to 3.6, and we'll change an episode name from coffee to tea, and let's save these changes by clicking on read. As you can see, the changes have been saved. Let's search for something, say the Oscar nominated film or the Emmy nominated episodes. You can even search for episode names such as tea. You can even change the column width by dragging the column borders. we have a sort function where you click on sort and you can choose the column name by which you want to sort the data frame, how you want to sort it in ascending, descending, or your own custom block. When it's on ascending or descending order, you can't change the block, it's fixed. However, if you click other, you can type your own custom block. Let's say we want to sort the data frame by season followed by the episode. So we'll click add, we'll select episode and again add. Now we can chain sort it. As you can see, it has been sorted on the basis of season, and where season is same, it has been sorted on the basis of episode. Thank you very much for listening to my presentation. Hope you have a great day.
Thank you. So the next will be a very short video, but nonetheless very interesting, from our student from Argentina, whose name was Ivan Javerbaum. He was the student of Noel, Guiche, and Pablo, and he was working on the Pharo to C VM transpiler. So this one. Yeah, it's very silent, so I don't think we can increase really the sound here, but hopefully you can hear something. If not, you can observe the screen.
So far, the two main features that have been developed are validations and computer namings. Let's start with validations. The idea behind these validations is to catch possible errors while transpiling that would normally arise when compiling C or words during execution. Two validations have been implemented so far. The first one targets scraps. In this clip, I'm adding a new instance variable that I forgot to declare its type. This validation won't let me finish transpiling unless all scraps have their corresponding type declarations. The other validation checks for type declaration structures reducement. The targets are local, which does not exist. In this case, on top of validating when transpiling, there is also a linter rule that works with the other side. System validations. Not just without the name. There are various reasons why one would need to rename to specify, but let's start with this example. On the left, we have a simple and valid Pharo project, which we would like to translate to C. The problem here is that the foo keyword is being used as a variable and a selector, and when translated to C, this will throw an error when trying to compile. We can differentiate between them. To solve these kind of issues, we must rename the variable, argument, or selector, and all its references to some identifier that won't have context. On top of that, to keep the code as clean as possible, the renamings will happen only when they are necessary. Here are a couple of examples. First up, we have the same code we were just looking at. We should choose two methods and a variable. However, when we take a look at the translated code, we can see that the full functions were translated as foo0 and foo1, solving the conflict between them, and the conflict with the variable, which remained as full as it wasn't necessary to rename. A fun variation of this happens when an identifier conflicts with a C keyword. As Pharo does not and should prohibit this, LAMP now renames them so it does not have conflict. In this case, we have a variable named return that gets named to return 1. There are a couple more variations, but they probably are for improvement. So that's pretty much it for me. Always a post this course in the Pharo VM repo, and for more info, I'll be going a bit more in depth about the development process in this flow. Thank you and goodbye.
Goodbye. So that was a silent video, but I could hear it, so I hope you could hear it as well. The next video will be from Viren Varma. So Viren is also our student from India. He was working on graph libraries integration and redesign under the supervision of Sebastian and Gordana.
Greetings to one and all present here. My name is Viren Verma, and I was a mentee at the Google Summer of Code under Pharo Consortium. under mentors Sebastian Jordan Montano and Gordana Rekik. My project was to redesign graph libraries and integrate new algorithms to it. A little bit about me. So I did my bachelor's in technology in mechanical engineering from NIT Karnataka Surathkal. I previously interned as a data analyst at Wells Fargo, and I've published two research papers in NMIT Con and CentCon. So I'll be speaking about my project at Pharo in the Google Summer of Code 2023. So our key deliverables were to redesign the graph algorithms API to make it easier to access and incorporate new algorithms like A star and longest algorithm for DAG and DCG. I was also tasked to complete the graph layouts library that was previously built and exploring new algorithms for this particular library. So starting out with my work, I coded out the A-star algorithm where I wrote specific test cases and I used distra as the heuristic function to calculate the heuristic value. I followed standard API practices and I took a reference from other algorithms that were coded out in the same library. Here's a small example of a test code as well as the kind of tests I wrote for A-star algorithm, and all of them work perfectly. My next task was to code out the longest path in directed acyclic graph and directed cyclic graph. So for this, I used a variation of topological sort algorithm for DAG and a variation of Bellman-Ford for DCG to code out these for two particular algorithms. Coming to the next part of my project, which was redesign graph algorithms test package. So basically, I had to shift all the fixtures that were already created for these tests from instance side to the class side and classify them on the basis of their weight, their cycle, the existence of a cycle in a graph, and their complexity. And I classified into these 6 classes, and most of them I redesigned this library this way. I also added a graph visualization feature or a functionality for it, which is something like this. So for each particular class, you can just inspect the particular class and see each visualization for each fixture. So that's how it works. Coming to the next part, yeah, so we also made a demo of this entire process and uploaded on YouTube, so you can see it over there. Here's the link for it. I'll forward it to Jordan and maybe he can forward it to everyone else at ASUG. The next part was working on completing the graph layouts library, where I changed the graph structure to add accessors for better node traversal, as well as I added a feature for code visualization as well. I fixed all the bugs that were there in the algorithm as well as in the test cases, and I wrote new specific test cases that would catch any new bug that's created for any new layout algorithms that would be created. Yeah, so here's a small demo of how it all worked. So this is basically the visualization of a particular graph, and over here is the particular class over here. So this is how that particular visualization works for each of the particular graph layout, and these are very say coordinate centric. So if there's a variation in one particular coordinate, that will be shown in the visualization. This is again, that was the box representation, this is the circle node representation. Next part was solving this problem, which is updating traversing nodes. And initially, the node traversal in find node was done linearly with a time complexity of O of n, and we explored a lot of PRs looking for a better optimized search using binary search method to bring it down to log n, but none of them worked properly, and we eventually went with mapping each of the node labels with the nodes in a dictionary and bringing the time complexity down to O of 1. So here's a small example for it. Here's the node dictionary where the entire mapping goes, and this gets built at the build time when the entire graph is being built. So eliminating of all errors. There's still a lot of scope for future work left. So for example, we still plan to create a separate external package for graph layouts and graph algorithms for a common graph structure, and this graph structure can be accessed by both packages externally, and I think this will be a more optimized way. I think that's the end of my presentation. Thank you so much, everyone. Thank you.
Thank you. So the final presentation for today will be from another student from India. that worked on a project called Complex Network Library on top of Pharo AI Graph Library. And he was supervised by, no, stop, go here, yes. He was supervised by Sebastian and Gordana. So can we make it better? No, that's the max. Okay, perfect.
Hi everyone, I'm Gautam, a fourth year student from IIT Guwahati, India, majoring in mathematics and computing. This summer, I had the incredible opportunity to contribute to the Pharo consortium for the Google Summer of Code. Under the guidance of my mentors Gurdana Rakic and Sebastian Jordan, I worked on the complex networks library. Today, I'll take you through the core components and the algorithms of this library. Let's start with the building blocks of our library. First, we have the network node class. This is the fundamental unit of a network. Each node has a unique ID and you can associate various attributes with it. And then we have the network undirected edge class and the network directed edge class. As the name suggests, these two classes represent an undirected edge and a directed edge respectively. And then we have the network attribute class. This enables us to associate nodes and edges with attributes like color, size, weight, or capacity. And then we have the most important class, the network graph class. So this represents the entire network, and it has methods that allow you to build the network, modify the network, or query the network. Now, let's move on to the heart of our library, that is the algorithms. First up, we have the assortativity. Assortativity measures the correlation between the degrees of nodes on either end of an edge in a network. If high degree nodes tend to connect to other high degree nodes, the network is assortative. If high degree nodes tend to connect to low degree nodes, the network is assortative. Here you can see various methods in the assortative class. And then we have the centrality. So centrality metrics highlight the most influential nodes within a network. Different metrics capture different aspects of influence. So here we have around 5 to 6 different centrality measures implemented. First up we have within centrality, second closeness centrality, and then degree centrality, in degree centrality, and out degree centrality. And then in out degree centrality, which returns both in degree and out degree for a particular node in a network. And then we have triangles. Triangles in a network indicate tightly connected triplets of nodes. Analyzing triangles can provide insights into the network's clustering coefficient and transitivity. And then we have clustering coefficient. So the clustering coefficient measures the fraction of a node's neighbors that are also neighbors of each other. It provides insight into the local structure of the network. So here we have all the methods related to the clustering coefficient. And then we have efficiency. So efficiency in a network measures how effectively information can be exchanged over the network. A higher efficiency implies a more compact and better connected network. So here we have global efficiency and local efficiency implemented, and also efficiency between two particular nodes in a network. And then we have distance measures. So distance measures in a network help in understanding the spread and structure of the network. It can provide insights into how quickly information or diseases in a network can spread. Here we have barycenter of a network, center of a network, diameter, eccentricity, periphery, and radius of the graph. And then we have cliques. So clique in a network is a set of nodes that are all interconnected. Detecting.
If you don't mind, we will probably fast forward this video closer to the end, because it's way too long for our presentation and we are running out of the time. So I will move it to the end. Yes.
Example
Please.
on how to use the configuration model class. So during my research journey, I explored the depth and breadth of network analysis and enhancing Pharo's capabilities. I would like to express my profound gratitude to my mentors, Gurdana, Rakic, and Sebastian John, for the guidance and the Pharo community for their support. As a wrap up, I invite everyone to delve into the complex network library, explore its feature, and contribute to its growth. Thank you.
Yes. Thank you for this nice invitation. So I will add some final words and I will give the stage to the next presenter. So to sum up this presentation, we will put all the videos on the YouTube and I will share the link with all of you. So like this, you will be able to watch them again and you will be able to watch the last presentation completely if you want. Also, I will create a form today so that I will also share with you when you can already start putting the ideas for the next year's Summer of Code. So like this, we can start collecting these ideas and like this, when the time comes to apply, we can already be ready to have some nice list of projects. Thank you very much.